Hello, I am Asma, roll number 47. This assignment 1, programming problem P7, hierarchical softmax with a human Huffman tree. Built the Huffman tree. First, I built a Huffman tree using the word frequencies from the vocabulary. Each word becomes a leaf, and the less frequent words are placed deeper in the tree. For every word, I store its binary path from the root and the internal nodes along that path. Instead of calculating a full softmax over the entire vocabulary, hierarchical softmax calculates the probability of a word by multiplying the binary branching probabilities along its Huffman path. At each internal node, a sigmoid is used to decide whether the path follow the left or right branch. For training, I derive and implement the gradients for both the internal node vectors and the context word vectors. These gradients are then used to update the parameters with gradient descents. The loss is accumulated over the internal nodes on the target word's path. Then I verify the probability distribution for a randomly selected context vector. I calculate the probability of every vocabulary word and sum them. The sum is approximately 1, which verifies that hierarchical softmax defines a word probability distribution. Next, I compare 3 output layers using the same corpus and training settings: full softmax negative sampling and hierarchical softmax. I compare their training time and final loss, and I also evaluate their nearest neighbor quality. Finally, I create a random binary tree and compare it with the Huffman tree. I report the average path length and training time for both trees. This shows how the tree structure affects hierarchical softmax training. This bar chart summarizes the training time comparison of the different output layers. Therefore, I implement hierarchical softmax with a Huffman tree, verified the probability distribution, compared different output layers, and compared Huffman and random binary trees. This